So this is my first setup for testing the PMG, Chinese PMG that I unboxed in the previous video. So I made these setups that I can adjust the distance between the belts and move these. But this setup won't be final, and I want to show you the reason why. But long story short, at the lowest RPM, this four-stroke engine is running too fast for this generator because it's rated at, I think, a maximum of 300 revolutions per minute. So I'm going to have to do something to reduce the velocity ratio between these and these, or increase the velocity ratio so that when this is spinning at top speed, I'm going to have 300 revolutions per minute on this one. But I thought it would be nice to just show you this setup. And then once I'm done with the other setup, I'll also show you that. And it's in the other setup that I'm going to put some actual loads on the generator to see how it performs. So yeah, let me get the generator started. I mean the petrol engine started, and then we can see what is happening. And yeah, I'm running it on LPG. So that's the minimum speed. You can increase the speed using this throttle here, but I'm going to run it at the minimum speed. And at the minimum speed, I'm not sure whether you can see this, but at the minimum speed, I'm recording a voltage of 470 volts or thereabouts. That's just too much. So let me see if I can use the other meter that can show you the frequency and the voltage. So you can see we are doing, we are at 79 hertz, doing 490 volts or thereabouts. So it will not be possible to run this at such speeds. You need to run it at lower speeds. But there is power generation and a lot of it, as you can see. And actually, if I shut it, it's just going to shut it down because the resistance on the movement is too much for that speed, and that is why I want to have a bigger velocity ratio, and I also want to make a flywheel mechanism, and that is going to deal with issues like the overload, because I also want to test some welding using this. I want to see whether it can be able to weld. I want to see whether it can be able to boil water in a 2000 watts kettle. But it's rated for 30,000 watts, so I'll try and put a load of 10 kilowatts on a single phase or between two phases, and we'll see whether it will be able to handle that. My main concern is about heating. I don't know how efficient it is, because if it's like 80% efficient, it means like that 20% of the energy being put into it is being wasted as heat. And I don't see any cooling fins or anything. I haven't opened it inside, so I'm not sure about how the cooling on this is done, or whether it needs it at high loads and long-running performances. So for this Pulley here, I could not find a match for this. So this has, the shaft on this generator was 30 millimeters, and most of the pulleys that I could find were in inches. So I got a 1-inch pulley, and I had some lathe work done on it to expand the hole and also expand the keyway to match this generator. I can show you more details about the dimensions of this if you want. if you'd like that, leave a comment, and I'll be able to show you the way that was done. If you also like to see how this setup is done, so these wires are just tensioners. I was intending to put some lead screws here, and then I'll be able to adjust the tension on the belt. But for now, I've just put in the wires because I've discovered I'm not going to be able to use this to test this generator because the speed is just too high. Yeah, and yeah, that's it. See you in the next video. Please subscribe so that you get notification when I upload more videos about the tests on the generator.